Okay, I just wanted to make one quick video on the section 5.2 in your book. And as far as it goes, as you kind of scan ahead in your book, for the most part, this chapter is all about the trig verification, which you've been doing for homework, and then a whole lot more identities, which you can verify using the exact same verification rules. As far as it goes, though, given this is an online class, you're clearly not necessarily going to have to memorize all of these formulas, because anytime you take an exam, you're going to have your book in front of you. So I figured if nothing else, you should understand how to use them. So I just wanted to make a quick video where we actually use this. In 5.2, we do the sum and difference angle formulas. I wrote 2 of them down. There's 2 more differences. I just wrote the sums down. But essentially, cosine of u plus v equals cosine u cosine v minus sine u sine v. And sine of u plus v equals sine u cosine v plus cosine u sine v. And again, the difference ones are the same, you just put the signs in the middle right there. The one thing I would stress, I know these are somewhat complicated, but if you know these and understand these, you can actually generate every other identity and formula in the entire rest of this chapter. There's like 15 or 20 of them. These ones right here generate everything. When I was in school, I didn't actually learn them as well as I should have, which made things harder. Now I understand how important they are, so I kind of stress them. So that's kind of my little aside there. Learn these. They're important and they're really useful. And they generate a lot of formulas mathematically. But to actually use them, we know from the unit circle a lot of angles in their sine and cosine. We have them memorized. 30 degrees, 45 degrees, 60 degrees, and so on. So what happens if I want to find the cosine of 105 degrees? Well, I don't have that one memorized. Is there a way I can generate it? Well, if I can write it this way, as the sum of 2 angles that I do know the cosine and sine of, then maybe I can find it. So maybe for this, I can say 105 degrees, that is 60 degrees plus 45 degrees. Clearly 105 and 60 and 45 are the same, so here I just expanded this, but it's the same problem. Well, now I can plug cosine of u plus v, 60 plus 45, into that sum angle formula. And this is the same as cosine 60 degrees, cosine 45 degrees, minus sine 60 degrees, sine 45 degrees. And those are all I know, and I would stress here again, as I have stressed before, I want an exact answer here. Do not put this in your calculator and give me a decimal. If you do that, it's going to be wrong on your homework and it's going to be wrong on your exam. We want to make sure we can use and apply this formula, so give exact answers. From the unit circle, what is cosine of 60 degrees? 1/2. What is cosine of 45 degrees? Root 2 over 2. Minus, what's sine of 60 degrees? Root 3 over 2. What's sine of 45 degrees? Root 2 over 2. And now I can, let's see, just multiply that out. 1 times root 2 is root 2, minus root 3 times root 2 is root 6, all over 2 times 2, which is 4. They have the same denominator. And there you go. What's cosine of 105 degrees? Root 2 minus root 6 all over 4. If you think about it, again, you can throw it into your calculator to get a numerical decimal answer. If you think about it, root 2 is clearly smaller than root 6, because 2 is smaller than 6. Which means root 2 minus root 6 is negative, so this is some negative number over 4, so my cosine is negative. If you think about your unit circle, 105 degrees is right over here in the second quadrant. In the second quadrant, cosine is the x value, it's negative. So on the unit circle, we know I should get a negative cosine, and when I plug it into the formula, I get a negative cosine. That makes sense, that's a good thing. And again, I reiterate one more time, this is the answer I want. I want them written like this. If you throw it into your calculator and give me a decimal, it's going to be marked wrong. Okay, and we're going to do one more. So in this one I wrote down, Suppose I want to find sine of 28 degrees times cosine of 17 degrees minus, plus cosine of 28 degrees sine of 17 degrees. And I want an exact answer, which means, again, don't just throw it into your calculator and get a solution. Again, as an aside, because I had trouble with these when I was in school, I had absolutely no idea what to do from there. The other direction I could do, this direction always confused me. But the idea is, if I call this U and that V, then that's U and that's V. And this is sine U cosine V plus cosine U sine V. Well, that's the sine sum angle formula, which means this whole equation, the thing I just erased, that whole equation right there is just equal to sine of U plus V. Or in this case, sine of 28 degrees plus 17 degrees. And now that one I can solve. Assuming my math is accurate, 28 degrees plus 17 degrees is 45 degrees. And then sine of 45 is root 2 over 2. And I'm done. And again, this one I'm aware can be a little bit tricky the first time you see it. You have to know the formulas well enough that when you see some big expression like this, you recognize that you can translate that into the sum angle formula for sine, and then solve out for the individual angle as opposed to both of them. You will be going back and forth, both in ALEKS and in your written homework from the book, so you'll get practice with it. And again, I can't stress enough, these ideas, these formulas generate everything we will do in this entire chapter. So do spend time kind of thinking about and working on these, because they will generate everything we do for the rest of the chapter.